So good morning, good afternoon, and good evening, guys, based on the time zones you all are coming from. So guys, before we start with the session, can you all please give me a quick confirmation if you all can see my screen and hear me loud and clear as well? Perfect. Thank you so much for the confirmation, everyone. So before we get started, guys, let me give you a small introduction about myself. So my name is Neeraj Kheria, and I have been working in this IT industry for more than 10 years now. So today we have gathered to discuss on Amazon EC2. So the main agenda for this entire session we'll be discussing on what exactly EC2 is, how it is structured, and how we can get started on using EC2 as one of the main services offered by AWS as a part of Elastic Cloud Compute. And then we'll be having a quick understanding of what exactly is AMI as an Amazon Machine Image, how to define the security groups, key pairs, and tenancy, what is the main difference between Elastic IP and public IP, and different types of EC2 box configurations available, and what are different AWS storage services available, and how we can optimize the costing in EC2. That will be our main agenda for this entire session today itself. Let's get started on a discussion on EC2 as an elastic cloud compute. So EC2 is a web service that provides servers in the cloud which are customized as per the requirement. So as we know, if we want to deploy any particular application, there are two ways of it. We can deploy the application in two ways. We can either buy our own servers, we can buy a stack of servers, and then we have to perform all the entire installation of all the operating system, the network, the drivers, the kernel, everything that we have, and along with the entire databases. Everything has to be done at our own end, right? Or we can use the services already deployed over cloud. So again, here we have already deployed and pre-configured server that we can use, that we can, on top of which we can simply deploy applications automatically as a part of cloud service. And EC2 itself is just like we create multiple servers, we create multiple VMs as in virtual machine. So same way here we have EC2. So these are again the servers that we deploy over the cloud platform, and that can be initiated in a couple of minutes as compared to the deployment on the on-premise servers. So here it can be configured, it can be up and running in less than 15 minutes. That's how fast it is. And in here, it is highly scalable. So now when we talk about scalability, suppose if we want to increase the capacity of these servers, we want to increase the capacity of these servers from 2 cores of RAM to 8 cores. We want to add more RAM here. We want to increase the storage capacity as well. So we can do that easily. We can do that easily using the cloud computing platform as compared to the on-premise server, right? So that's the main advantage of, again, going for cloud platform as compared to on-premises. And the main advantage that we get on top of cloud services is it is highly scalable, plus it works on pay as you go model. So here we don't have to pay any upfront cost, because as compared to traditional, or we can say as compared to on-premise servers, because in on-premise servers we have to pay for setting up the servers, we have to pay an upfront amount for the infrastructure for the servers that we'll be buying, right? Whereas the cloud services, especially if you talk about our EC2, it works on a monthly billing cycle. So we don't have to pay any upfront cost or any fixed cost every month. And here we have to pay only for the amount of time we have used resources and the duration for which we have used them. That's the main advantage that we get as a part of EC2 deployment. And in terms of EC2, again, here we have Elastic Web Scale Computing. Again, it is highly scalable, it is highly flexible as well. Plus, again, it is scalable. That means if we want to add up resources, we can do that easily as compared to the on-premise server. Suppose if you want to increase the capacity here, if you want to add more number of servers, then that is done easily as compared to on-premise. Now, next is we have AMI. We have AMI. AMI is simply Amazon Machine Image. Now, just to understand this in simple layman terms here, if we are deploying any virtual machine, we do have to choose the operating system, right? Operating system, or suppose let's say when we are taking backups, For example, if we want to take the entire backup of our entire system here, what we do, we take a backup which contains not only now this backup file. Suppose if this is a backup, then what it contains is it not only contains the entire operating system, but it also contains all the configuration that we have done, right? It also contains all the files that is available on our entire system here, all the files, all the configuration, all the settings. That means entire particular system itself will be replicated if we are using this particular this particular snapshot or this particular image that we have currently created, right? And suppose if we create an image out of it, right? Suppose if we create an image out of it, suppose let's say we have a disk image for ISO, right? If we share this image to anyone, then using this image, suppose if they have a blank system, they can use this image to make a copy of whatever is present in this entire image. The entire configuration, files, and operating system can be replicated on their own system using the concept of images, right? And that's what images. So images are, now they are some predefined images which contains the predefined configurations that we can choose to get started with. Like we can choose the Windows instance, Windows AMI, we can choose Ubuntu, we can choose Debian, CentOS. Depending upon our use cases, we can choose these predefined images that we can simply use to install and set up our VM, or we can say install and set up our servers as an EC2 that we want, on top of which we can get started and start customizing on top of it, right? That is what we mean by AMI, Amazon Machine Image here. All right, next is we have security groups. So security groups is now when we are deploying servers, obviously as a part of server, server will be required to have a connection to as well, right? Because when we are deploying a server, we also need to have a connection, because suppose if we have deployed a server, now in order to manipulate, in order to work on the server, we need to establish a connection to the server itself, right? So which all ports will be used for setting up the connection here? TCP ports, HTTP, HTTPS, or SSH ports here. So which all ports will be used as a part of connection that we have to define as a part of security group, right? So in networking, we have multiple ports. So which port will be using for establishing our connection with the server? That is what we define as a part of security group. Suppose if we want this to be, suppose if we are using a TCP port, right? And now in TCP, we want the access of this one on port 8080, on port 8080. Then we can define this as a part of security group. We want to access the server through the HTTP port here, right? Suppose here we want to define this as a part of HTTP, so that if we type in the IP and the HTTP ports here, again they will be able to allow us the access to the server here. So whatever port we want to add, we want the access to, we want the access from, we can define this as a part of security groups in EC2. So now let's erase this up. Now let's do one thing. Now let's move on to our hands-on, so that we can, so now we can discuss on each and every topic, seeing how exactly to get started on top of AWS EC2. So now let's log into a console first. Now, in case we don't have the account, or in case either we are having the account, in both scenarios, we can use this link as console.aws.com. So here we can use console.aws.amazon.com, which will take us to the login screen where we can start registering for AWS. In case we don't have the account yet, or in case we already have the account, then we can log into our portal here using the AWS portal. So here now, suppose if we don't, now here if we don't have the account here, we can click on create a new AWS account. In case we don't have the account yet, we can click on create a new AWS account, and this will take us to the sign up page where we can get started on signing up as a new user, just like we sign up for other websites. So here we can sign up for our new account here, guys. And once we move on to the next screen, we have to now, as a part of successful completion of the sign up process, we also have to pay, we also have to add our card details. It can be debit or it can be credit card, both. And again, in order to start, in order to activate our account for AWS, we do need these details. And AWS will simply charge our card for a nominal fee of 1 INR that will be reversed as well after it has been charged, just to validate the card that we have added is working fine or not, right? So we can use any of our card details in order to enter that in AWS and get started. So here, once we have the account created, we can log into our console. Let's go right back. So here we can enter our credentials. Just a moment, guys. We're just simply setting up the MFA again, because again, this as a part of making sure the entire account is set up properly, we do need to set up the MFA here. Just a moment. Now, once we log into AWS, this will be our home dashboard that we'll be looking at. So this is our home dashboard on which we can get started. Now in here we can find, in here we have done, in order to start with EC2, we have to search for the service called as EC2, or we can use a search tab to find any services on top of AWS. Because AWS, as we know, is a collection of more than 90 plus services, ranging from computation to management and governance, storage services, database, analytics, media services, mobile, AR, IoT. So these are all different services, in total of more than 90 plus services offered by AWS here. So here we have to start with EC2. So here we can simply select EC2 here, and this will show the list of all the active services into our account. So let us open up. So as you can see here now, in order to start creating the instances, we have to click on this option which says running instance. So using this, we can go ahead and we can go to the instance that is currently being deployed, that is currently up and running into our account. And again, if we want to get started on creation of a new instance, we can click on launch instance, available on the top option. Here we have launch instance. Let's click on it. Now, as a part, just like we create any virtual machine using, like if we create any VM, first of all, we have to choose the base image as an Amazon machine image, AMI. So there are multiple predefined AMIs available as a part of our AWS account, so that we don't have to worry about using our own AMI. So we can use these as a base AMI. We can use these as a base application. Also, we can say base operating system and configuration, on top of which we can get started on deploying our own application on top of these. So here we can choose from a simple Amazon Linux server. We can choose Red Hat, SUSE, or Ubuntu server. Again, we can also choose multiple instances of Windows servers, Ubuntu. Again, there are multiple AMIs from which we can choose and get started, right? So we can choose any of these AMIs here. Now, as a part of our hands-on, we'll be choosing the Ubuntu server AMI. We can click on select. Now, in here, in this screen, we have to choose the instance type. When we say instance type, we simply mean the server type. That means what exact configuration we are looking for in order to deploy this entire server here. So as you can see, currently we have T2 micro selected. Now, as a part of our new AWS account, we get selective services that we can use under limitation for free, right? So there are some, as a new account, if you register for a new account on AWS, then we are given a couple of services that we can use for free under certain limitations, right? Where T2 micro is one of those free services. And as you can see here, currently we can see the list of the name of all these different services as in instances, and how many cores of CPU they have, how much of RAM they have, and again these different storage types that they are available as a part of this entire deployment here. Suppose we want 1 core of CPU and we want 1 GB of RAM. Suppose if we want the 48 cores of CPU and we want 192 MB of RAM, we can choose, and again we want two 900 MB. SSDs as a part of the storage options here. Then we can choose these accordingly. So depending upon our configuration, the cost will also change accordingly, because the higher the amount of resources we use, the higher the billing would be, because again these resources will be expensive, and that's why we have to pay a higher amount of money as compared to the lower, or we can say low resources, as in 1 GB of RAM and 1 core of CPU. So as an example here, we want to deploy the application on a free tier account here, having 1 core of CPU and 1 GB of RAM. We can click on configure instance detail. So here we can choose the T2 micro. Now next is we have to click on next configure instance detail. Here we can choose the instance number of instances, that means how many instances we want to deploy here. We can this part is mainly focused on the networking. Suppose if we want to create our own VPC, we want to create this on our own VPC, our own virtual private cloud here, then we can deploy this easily. And in this part here, we'll be focusing once we start a discussion on VPC itself. So we can leave this as it is for by default. Next is here we can add storage, as in what that means. In server, we also need to work on servers, right? And what kind of storage we will need in order to deploy the server instance here, that we have to define as a part of storage services. So here we can define how much of space we require for this entire VM that we are trying to create here. We want to use 8 GB of storage, we want to use 10 GB of storage, we want to use 100 GB, 1000 GB, depending upon our use case. Suppose we wanted to deploy this with 15 GB of storage. And in here we can choose a storage type. We mainly use general purpose SSD for we can say for a balanced. Okay, wait from someone. Yeah, so basically we use general purpose SSD for a balanced performance, where we can get good performance as compared to other storage devices, because SSDs are generally faster in read and write access and read and write speed as compared to other services, right? So here we can choose general purpose SSD, and then we can choose the provision IPS, especially when we have any data centric application. If we have any database applications, then we can choose data, or we can say provision IPS. And then in terms of any cold storage, if we are using this just as a backup, we are not using this for an active installation, then we can go ahead and use magnetic. So for our hands-on here, we'll be using general purpose. Then we can and in here, once we add storage, then in here we can add tags. We can leave this blank for now. And then we can define security group. If we now by default, we will be trying to access this via SSH portal. And now if we want to access this instance, this server also, suppose if we are deploying a website, then website will be opened up using the HTTP host itself, right? HTTP or HTTPS, right? So if we are deploying a website, then we have to choose the HTTP and HTTPS ports as a part of protocol, as a part of security group that we had discussed. So here we can click on review and launch. Once we are done, we can launch it. And as a part of configuration followed by AWS, each and every instance is highly secured using the concept of encryption. So the entire data available on the server that we deployed here is highly encrypted. And if we are trying to access this, if we are trying to make changes to this instance, then we have to use the key. That means unless we have the key that has been generated by AWS, we won't be allowed to connect to the instance. We won't be allowed to do any changes on the instance unless we have the right key selected and deployed here. Right? So here we can simply, here if we want, we can go ahead and create a new key pair. We can click on create a new key pair. Suppose we want to name this as nav21. We can create a new key pair. We can download this key pair and click on launch instance. Now remember to save this key pair that is downloaded as a in the format of .pem, because we will be needing this key file in order to connect to this instance, without which we won't be allowed the access. So without this key that we are currently downloaded, we won't be allowed the access in any case. So we have to make sure that we do end up saving this entire authentication code itself. And once we are done, we can simply click on view instances. So as you can see, now we have the instance up and running here, right? So now here we can, now once we have let's see how we can connect to the instance that we have currently deployed here. So here we can simply go ahead and open up PuTTY. First of all, now if we are using PuTTY, first of all, we do need to convert the .pem file as a, now this is what a simple key that we have currently downloaded, which we will need in order to connect to this instance, right? So first of all, in order to use it with PuTTY, we have to convert this .pem file to .ppk as PuTTY public key, because PuTTY needs ppk key files in .ppk format, not in .pem. So here for converting .pem into .ppk, we can simply use a tool called as PuTTYgen.exe, which we can download from the link that I have shared with everyone. So here we can download PuTTY.exe and PuTTYgen.exe as well, right? So here we can open up PuTTYgen.exe, and in here we have to click on load. Now, once we click on load here we have to go to the folder where we have downloaded the current key file in .pem format. So if we choose all files in downloads, if we search for .pem, now this is a key that we have currently downloaded, that we have currently used for the instance that we have currently deployed here, right? For this instance. So now what we can do, we can simply go ahead and open this up, click on open. And now we have to click on save private key. And let's save this on desktop with the same name as nav21.ppk. We can save it up. Now, once we have saved the key as .ppk, we no longer need this key. So we can close it. And now we can open up PuTTY.exe. We can open up PuTTY.exe. Now, once we have converted the key here, then we can simply open up PuTTY.exe, where first of all, we have to enter, now in order to connect, first of all, here we have to enter the host name. So we can enter, so now we can enter both the public DNS or public IPv4. We can enter both. We can copy this. We can copy this under host name of IP address. We can enter this IP. Port number will remain as it is, as port 22. Then under connection, we have data. So under data, we have to enter something as Ubuntu. And under Ubuntu, then under SSH, here we can expand SSH. And under auth, we can define the key that we are currently trying to create here. So we can use a key that we have currently converted, that is November21.ppk. We can open this up. And now if we don't want to do the same step each and every time we are trying to connect to the instance, then we can save this as a profile. So let's name this as nav21 itself. Let's save it. And now if we double click here, now if the credentials are correct, if the key that we have chosen is correct, we would be able to log into the instance here. As you can see, now we have got the access to the instance, and now we can start communicating it as a part of CLI. Let's increase the font size, as we don't want to strain our eyes here. Let's increase the font size. So that's how we can get started and get connected on top of EC2. Now, once we have the connection, we can start manipulating EC2 service exactly as per our requirement. So in here we can, now if we want, now this works like a simple shell scripting, right? So if we are comfortable with shell scripting, this works just like a shell scripting here. So in here we can, now in order to get the complete access, we can convert ourselves to the root user using sudo su. Now if in case we have chosen the default Linux environment, then we could have chosen yum, right? And in here, since we are interacting with Ubuntu, so then we can start using all the sudo commands, right? So like for example, here we have converted ourselves to the root user. We can clear this all out. And then suppose if we want to update or resync all the services, we can use apt-get update, where each and every packages will be updated. Suppose if we want to install Apache tools, we can simply go in apt-get install Apache 2. So here we can simply run and set up Apache 2 here. So once we are done, so since we have also chosen HTTP port as well for this entire instance, right? So once we are done installing Apache 2, if we open the same IP into the web browser, we would be able to see the default Apache 2 page being opened up in the browser. So let's wait for this entire instance to be executed. This which may take a couple of seconds. So as you can see, now this entire setup is done. So if we come back, if we copy the public IP here, if we copy this in and paste this in browser, as you can see here, since we are done with installation of Apache server, now we can see the Apache 2 Ubuntu default page being opened up in the browser in the instance, in the EC2 instance that we have currently deployed here. And that's how we can start manipulating it. That's how we can start working on top of it, right? Let's also discuss shortly on top of the IP addresses. Basically what we have is in AWS, we have something as public and elastic IP as well. So we also have something as public and elastic IP. So when we deploy EC2 instance, what we have is, now as you can see here, we have the IP being automatically assigned to the instance that we have currently created, right? But this IP, suppose if we no longer need these instances, we can simply click on actions, instance state, and then we can terminate these as well. When we say terminate, that means we are simply killing off the servers. That means we cannot restart this if we have killed it, if we have stopped this, if we have terminated this, right? If we stop their services, then we can restart them. But again, if we terminate them, then again, these entire servers here will be terminated. So I think we have terminated that. So here, once you click on launch another instance, if we choose to launch another instance here, click on select, review and launch. As you can see, these two have been terminated. Let's remove these. Now we have one instance up and running here. So as you can see, currently this IP address has automatically been assigned to this instance, right? And now if we stop this instance here, now currently we can note down it is 13.232.108.136. If we stop this, and again if we restart the same instance, then a new IP will be assigned here. So every time we start and stop and restart, and the servers here will be assigned a new IP to the servers, to the instance that we are currently deployed on top of AWS, right? And so this entire public IP that gets reassigned every time we restart the service, this is referred as a public IP. This is referred as a public IP in EC2. Whereas if we don't want this IP to be changed every time we are restarting it, then we can choose something as elastic IP. We can choose something as elastic IP here. So if we click on start here, again, if we start the instance again a new fresh IP will be assigned here. So let's wait for a second for this one to be up and running again. As you can see now, fresh IP has been assigned here, and basically the use case for the, and again, and if we do not wish to change, if we do not wish to change the or have the IP change every time we are starting and starting or stopping the servers, starting or stopping the instances here, then we can use something as elastic IP. We can use something as elastic IP here. So again, a simple use case for this one would be,
suppose we have an office, right? And any office here, suppose they're using an enterprise solution. Now they are using a solution which is used by their workforce from 9 a.m. in the morning. And kindly excuse for this beautiful calligraphy, guys. That's what happens when we try to write using our mouse pointer, right? So again, in the office, guys, again they are planning to use the application from 9 a.m. in the morning till 6 p.m. And that means from 6 p.m. in the morning, 6 p.m. till next morning 9 a.m. the application will not be used, right? The application will not be used. That means here we are simply wasting 15 hours of our work time here, right? So for 15 hours straight, this entire application will not be used. That means the entire servers will not be in use here, right? So instead of keeping the server on and which will be adding to our billing, because this works on a pay-as-you-go model, what we can do, we can turn off, or we can say we can stop the servers in this time period, right? But whenever we are stopping it, the IP attached to this instance that we are currently using here will be changed every time we restart them, right? Suppose that the same application is used by 1,000 users, then again we have to reshare a new IP to those 1,000 users every day, becoming and increasing the, we can say making it a more tedious task, right? So instead of doing that, what we can do, we can simply assign something as elastic IP, which will remain static, which will not get changed even though we stop the servers, right? So then in that case, even though we have stopped the servers, again, if we restart, the IP address will not be changed. And that exactly is what we mean by elastic IP here, being one of the use cases. And now in order to issue an elastic IP here, we can simply go to elastic IP. We can allocate a new one on, obviously elastic IP is a paid service offered by AWS. And when we say paid service, as long as that IP, this elastic IP is being used, we don't have to pay. But if we generate an elastic IP, and we are not using it, that means we have not associated that IP with any particular instance, then we have to pay for the unused elastic IP. That's a concept here. So here we can simply click on allocate, and once this IP has been allocated, we can close it. And now if we want to associate, we can click on associate address. We can choose the instance that is up and running, click on associate. And now if we come back, if we close it, if we come back to instance, now even the IP now has been converted into blue, right? And that means even though we start and stop the services, this IP will not be changed at all. So I guess it's almost time now, guys. So let's say we wrap it up for today. Thank you so much for joining, guys, and have a great day ahead. Take care. Bye-bye.